Hello and welcome to this video lecture series on data structures and algorithms with Python. So let us look at what data structure is. A data structure is a group of data elements that provide the easiest way to store and perform different actions on the data of the computer. A data structure is a particular way of organizing data in a computer so that it can be used effectively. The idea is to reduce the space and time complexities of different tasks. Okay, so what do we mean by data elements? We will learn about it in the coming videos. I'll just go briefly in this video about all the data structures that we have. But basically, data structures help us in organizing data and to be able to access as well as to store data effectively so that we can use it very efficiently. Okay. Types of data structures: linear data structure and non-linear data structure. So what are linear data structure? Linear data structures has elements where the elements are arranged in one dimension. Okay, examples of linear data structure would be lists, stacks, queue, etc. Linear data structure is further classified into static and dynamic data structure. So what do we mean by static data structure? Static data structure has like the memory size is fixed. Okay, we do not have a changing memory size, whereas in case of dynamic data structure the memory size varies based on the requirements. Okay, so non-linear data structure: elements are arranged in one or many dimensions in non-linear data structure. Okay, examples are tree, graph, table, etc. So let us look at some of the popular data structure we know. We have array, linked lists, stack, queue, binary tree, binary search tree, heap, hashing data structure, matrix, and tree. So now let us look at each one of these data structure. So first of all, we have array. An array is a collection of data items stored at contiguous memory locations. By contiguous, we mean next, like adjacent to one another, where the borders are touching. The idea is to store multiple items of the same data type. Okay, so we have this array, then these are indexes. Okay, it starts from 0, 1, 2, 3, 4, 5 like that, and it carries on. Okay, and these are the data values, okay, which are stored in the array. Like arrays, linked list is a linear data structure, but unlike arrays, linked list elements are not stored at contiguous location. The elements are linked using pointers. So as you can see in the diagram that the memory locations of the data are not next to one another, but there are some pointers that is directing to the location of the data. We'll get into linked list. We'll discuss everything in the coming videos. I will have a separate dedicated videos on all these data structures that we are going to discuss. So this is just an introduction to all these data structure. Okay, let us move on to the next one. Stack is a linear data structure which follows a particular order in which the operations are performed. The order may be LIFO, which means last in first out, or FILO, which means first in last out. In stack, all insertion and deletion are permitted at only one end of the list. Okay, so basically stack is nothing like it's more like when you are stacking books on top of one another. So the book which you started with is removed. Suppose you have a box where you place all your books. So the book, suppose you place book number 1 first, book number 2 second, like that, and we have 5 books. So we have like book 1 goes in, book 2 goes in, book 3 goes in, book 4, and book 5. So now if you want to remove the books, we'll have to start with book 5, right? We cannot remove book 1 first. So that is the central idea of stack. Now mainly 3 basic operations are performed in stack. The first one is initialize, which is making an empty stack. The second one is push, which is adding an item into the stack. If the stack is full, we have an overflow condition. Next, the next method that we have is pop, which is removing an item from the stack. And if the stack is empty, then we have an underflow condition. The next method is peek or top, which returns the top element of the stack. And the last one is empty, which returns true if the stack is empty, otherwise it returns a false. Okay, so now let us look at the next data structure that we have. Like stack, queue is a linear data structure which follows a particular order in which the operations are performed. The order is first in, first out. In stack, we first remove the item most recently added, while in queue, we first remove the item the least recently added. So queue basically means when we go to a supermarket and we have to stand in a line, right? So the guy who goes in first has his bill, the bill is taken care of and he's able to leave first. Okay, then the second guy goes in, and third and fourth and so on, right? So that is very much similar to how queues in data structure, queue as a data structure, work in computing, right? So let us now move on to the next data structure, binary tree. Binary trees are hierarchical data structures. A binary tree is a data structure in which each node has at most two children, which are referred to as left child and right child. It is implemented mainly using links. A binary tree is represented by a pointer to the topmost node in the tree. If the tree is empty, then the value of root is null. Okay, a binary tree contains the following: data, pointer to the left child, pointer to the right child. Okay, and that continues as we go down. So next we have binary search tree. A binary search tree is a binary tree following the additional properties. So let us look at the properties which makes a binary tree qualify into a binary search tree. So the left part of the root node contains keys less than the root node key. Okay, and then the right part of the root node contains keys greater than the root node key, and there is no duplicate key present in the binary tree. So we can see that in this case we have 40 as the root node, like the value of 40 stored in the root node, and we can see in the left nodes the key values are lesser than the key value in the root node. We have 30, 25, 35. Whereas in the right nodes we have key values which are greater than the key value in the root node. So this is the fundamental property which qualifies the binary tree into a binary search tree. Next we have is heap. A heap is a special tree based data structure in which the tree is a complete binary tree. Generally, heap can be of two types: max heap and min heap. In max heap, the key present at the root node must be greatest amongst the keys present at all of its children. The same property must be recursively true for all subtrees in that binary tree. For example, if we look at this one, this is our max heap, where this is the root node, and the key value stored in the root node is greater than all the other children, right? And as we move to the next to the children of 6, we have 5. Now 5 has children these two, right? But the value stored in this node, which is 5, is greater than all its children. Similar is the case with 3, right? Next we have is min heap. The key present at the root node must be minimum amongst all the keys present at all of its children. The same property must be true for all subtrees in that binary tree. For example, this is our root node. So 1 is less than 3 and 2, 3 is less than 4 and 6, 2 is less than 5. So this is an example of min heap. Next we have is hashing. Hashing is an important data structure which is designed to use a special function called the hash function, which is used to map a given value with a particular key for faster access of elements. The efficiency of mapping depends on the efficiency of the hash function used. So we have some input values, then we have the hash function. For example, we have x modulus 7. I'll explain the function, and then we have hash keys. So for example, I have 7. So 7 modulus 7, which is 7 divided by 7, we have a remainder of 0. So the value of 7 is stored in the 0 position, right? So similarly, we have input of 16. So now if you divide 16 by 7, 16 by 7 gives us a remainder of 2. So therefore, the value of 16 is stored in the second position. Okay, so like that we can calculate the positions where to keep our input values. Next we have matrix. A matrix represents a collection of numbers arranged in an order of rows and columns. It is necessary to enclose the elements of a matrix in parentheses or brackets. This is very similar to the one we do in like maybe when you go to class 11th or 12th, you will come across matrices, right? So it is very similar to that. So this is like a 3 by 3 matrix where this if we go horizontally, these are rows, and if we go vertically, these are called columns. Okay, so next we have tree. A tree is a data structure that is actually a type of a tree, but it is often used to store characters. It is used to store strings that can be visualized like a graph. Each node consists of at max 26 children, and edges connect each parent node to its children. Okay, so I think this is it for this brief introduction to this data structure. I'll go in depth with each one of these data structure. So I hope if you like this video, you will like this video, share it with your friends, and please subscribe to this channel and hit that bell icon so that you get notified every time I put a video. So thank you so much for sticking by, and hope to see you soon.